All right, good evening. This is live training from Unity Technologies. My name is Adam Buckner, and tonight's session is an introduction to editor scripting. We're going to be looking at property drawers and custom inspectors, but today is primarily going to be, as I said in chat, an amuse-bouche, or a little light taste of editor scripting, just so that we get an idea of what editor scripting is. But as I said, today is going to be a little bit of an under-structured class compared to some of the stuff I normally do. So today we're talking about property drawers, custom inspectors, and this is going to be an introduction to editor scripting. Now, editor scripting allows us to build tools and add menu items and automate processes and tasks in the editor. We can create editor windows. We can create editor wizards. As a matter of fact, the entire editor that you're looking at was created using editor scripting. The Unity builds the editor that you're looking at using the same editor scripting that we use in our editor. So editor scripting uses an immediate mode UI. And this is the UI that's called onGUI, after its famous function that we all use. So I'm going to go ahead and just take a look at the documentation that we have here. This is going to open up in another window, I'm sure. Yes, it is. And then we're going to go to documentation. We're going to go to the documentation site, and then we're going to look at our manual. And where you need the basis of doing everything that you want to do with editor scripting, you want to do with our GUI, called onGUI. So you can do a simple search for GUI, and the first thing that comes up is the GUI scripting guide. And part of what we're going to do today, that we're not going to go into extreme detail in this particular session, and you're going to need to do a little bit of your own homework. To be able to understand onGUI, you're going to need to run through the GUI basics here in the GUI scripting guide. And this talks about how you can make controls in Unity GUI. Now, don't get confused with this UI, Unity GUI or onGUI, compared to the new UI tools that we are using in our games. The new UI tools, which are in beta, in 4.6 beta, and are going to come out in momentitos, I think. We're going to see that soon, and also it's going to be the main UI going forward. In 5 is a sprite-based UI. It's a retained UI, but the editor is still going to be done inside onGUI, inside Unity's onGUI, or the Unity GUI. And it is an immediate mode UI. It is a script-based UI. And so this is something that you're going to need to spend some time sitting down and working through. The reason why it's immediate mode is that it has code, and the code defines what the UI is going to be. And then every frame, Unity reads all of the UI code that's there, and this also works in the editor at edit time. It's refreshing, so many frames a second. And so all of the menus and all of the inspectors that we see in Unity are being driven, the hierarchy, the project, the inspectors are being driven by this particular scripting code. It's also worth noting that even though the editor does refresh and redraw, it's not done in a loop like in a game that we have written. The editor redraw is event-driven. For example, when the mouse hovers over an item and a tooltip needs to be drawn, or a click is detected, and that changes the state of the editor. So you will need to go and find that. You'll need to run through this, the GUI scripting guide. I'm going to pop this into chat. And this is what we're going to be writing our scripts in. Some examples of some of the things that you can do with Unity scripting, and I've popped in a couple of tools here, is that you can create tools that go into the menu bar. And this is somewhat of an outdated tool. We'll go ahead and look at this. This is a tool for aligning to the ground that I wrote a couple of versions ago. But it still holds true for when we look at a particular script. Now I have to remember where I put it. Line with ground. There we go. And let's go ahead and take a look at this. I'm going to go ahead and expand this up to you. Get bigger. There we go. But I just want to give just an example of editor scripting. So what this does, we are using our Unity editor. It's the namespace for the editor. This is making a public class called Align with Ground. And this is being put into the tool menu. And then we go ahead and just use normal logic as if we're writing a script for our game. And we're doing looking at transforms that we're picking up. We are casting rays into the scene. We're looking for hit points. And we are moving our objects just as if we were doing that in the game to go ahead and align to ground when we're doing this in the editor. And so when we come back to the editor, we'll find that tool up here in the header bar. So it's aligned with ground, and you can go ahead and you can give that a command. We will link the, you can look up the command tools in the documentation. I'll also link that when we put this up on the website. So one of the some of the other things that you can do. I also wanted to show you this particular script as well with editor scripting. This particular script, this is not to do with custom inspectors, but again, it just has to do with editor scripting and the things that you can do with editor scripting, is one of the utilities that I used. I haven't updated it recently, but it's an asset post-processor, and this automatically sets my UI element. You can place this in your editor folder, and every time you import a new image, if you import it into a folder that contains UI images or a folder that contains sprite fonts, because at the time I was writing my own, I had my own sprite font atlases, or sprite atlases, then it would go ahead and run the texture importer and set those settings to what I wanted them to. So I could make a watch folder where I had a folder, and that watch folder could be images. And then inside that folder, I could then have a folder that was textures, and I could ignore anything. The textures would have their own importer, but I could then have a folder that was called UI images. And at the time, we should just be aware that this particular one has spaces in it. Spaces most of the time are perfectly fine, but there are some functions that will fail if there's a space when you're looking at paths. Some work and some don't, so I now recommend that you don't have spaces in anything that contains a path. And then if I have my folder and I put new material into those UI images, it's going to be processed along with the settings that I've included in this particular script. So again, just an idea of some of the things that you can do with editor scripting. If you ever got to that point where you import an image and you've got to set it all up, and you import another image and you set it all up, and then you import this one and it needs to be a sprite and you got to change it, and then you import another one, it needs to be a texture, you can make watch folders. You can write a very simple script, place that script in the editor's folder, and it'll be processed for you automatically. Another example is that you can change the inspectors. And so the things that we're going to be looking at today is sort of three-tiered. We're going to talk about making custom inspectors, where you change the entire inspector of an object. We're going to talk about property drawers, which you can, with property drawers, you can either change the way that you look at a serialized class, or you can make a property drawer that can work on a serialized field inside a script. One other example of a script that I worked on, and this is partly why we're not going to go through all of these in specific detail, as you can see that they can grow a bit large, and this is intermediate scripting. And this was before we could copy and paste transform values. Again, a little bit old, but I wanted to show you something that could be done. And this replaces the transform inspector. And you can see that we now have down here a show transform tools, and I could copy the transform, I could paste the transform, I could choose which properties, whether it was rotation, position, and scale, that I could pick, and I could pick all or none. I could copy that, I could paste that into another transform. Now this has been superseded inside Unity by being able to copy the component and paste those component values. But in an earlier version of Unity, when that wasn't there, my solution was to write a custom inspector that allowed me to grab all of that material. And you can see that we have that custom inspector for type of transform. So you can also replace, custom editor for type of transform. You can replace the existing components that are here inside Unity. So if there's something that you want to change, even if it's the transform, it doesn't have to be a custom class that you've written yourself. So dealing with extending the editor, we need to keep a couple of things in mind, keep a few things in mind. The scripts that extend the editor need to be placed in a folder called editor. You can have multiple editor folders, but you need to have at least one, and it has to be inside the asset folder somewhere. So it has to be inside our project view. So as long as you have it inside the project view and you place your editor your editor scripts inside that editor folder, then Unity will go ahead and process them at edit time as long as they're properly extending the editor. There can be several editor folders, but there needs to be at least one to be able to hold our editor. So when you're organizing your scripts, I mean, what I've done here is I've made a demo script. I had some other material there, but I've removed it. So and I've decided that we can have attributes, and we have our editor, and we have our scripts. So I have organized it, and I could make another editor folder in another. I could have a demo, I could have tutorials, I could have another editor in there, but the editor scripts do need to go inside the editor folder. The other thing I'm taking advantage of, a little tip here, is a thing called web player templates, which works for avoiding compilation. And it needs to be spelled exactly the same way with the capital T and the capital W and one word, but it'll allow me to do certain things like I'm now going to remove that tool, the Align with Ground tool. Bink. And I'm going to also remove that transform inspector, which we don't necessarily need. And we're going to get some null references because the editor is trying to find stuff while it's going, but now that it's recompiled, they're gone, and we can come back and we can see that the transform's back to the way that we'd expect it to be. So we've removed the transform inspector and removed Align with Ground by putting it into web player templates. Those are there primarily for actually defining the code for a web player template in our player settings, in our build settings. But coincidentally, you can put other scripts in there and they won't compile. So let's go ahead and look at some of these existing scripts. And let's take a look at making a custom editor. And so let's say we have my player. Don't save. So we've just got a very simple script called my player, and it has some public properties, 2 ints armor and damage, and a game object called gun. And if we were to put that in on a demo object, let's just make a game object. Let's just call this demo object. And if we go ahead and put that player script on the demo object, I didn't want to do that. I wanted to have that hidden so we could see what it looked like without the custom inspector. Okay, come on. There we go, recompile. There we go, that's the type of script that we would normally expect to see, where we've got one property, we have a field to be able to fill it in. This gets even more complicated when we're dealing with custom classes, which we'll talk about in a second. Relatively straightforward, but also relatively ugly. And there are times when you either want to make your inspectors look nice, say you're selling something on the asset store and you want your inspectors to look nice, or you're making something for your team. You need to get more functionality out of your inspector so it's easier to use, so that you have quicker ability to put your game together when you're rushing for a deadline. So what we can do is we can make a custom editor for that. And this is a particular custom editor that we can see we are using Unity Editor. We need that namespace to be able to use it. We are telling it that it is a custom editor, and the custom editor is type of my player. So the syntax that we have for this is that you need to, and I'll just duplicate this just so we can see it. So you need to have your square brackets. Inside your square brackets, you have to identify this as being a custom editor. And then you have to tell it the type, which is going to be my player. But you also need to cast for this. So you need to make sure that you say it's type of my player. And so that is how you identify this particular script. This attribute will identify this particular script as a custom editor. The next thing that we are doing is we are allowing multi-selection editing. Without can edit multiple objects, if you selected 2 or 3 of the same type, you're going to get that error that multi-selection editing is not enabled. So if you want to be able to select multiple game objects or multiple game objects with these components on it and be able to edit them, you'll need to be able to have can edit multiple objects enabled. Now, the next approach to this, which is important to look at, is to realize that we are grabbing here some serialized properties. You don't have to, but when you grab serialized properties, you are enabling lots of wonderful things, including the multiple selection editing. You're also enabling undos. You're also making sure that prefabs work properly. So the best thing to do here is to grab a serialized property inside your custom editor, and then we'll go ahead and find that property on the class that we're dealing with. And we can do that here is on enable. So when we start on enable, we're now going to find our serialized properties. by looking at our serialized object, which is an automatic reference that we get with our custom editor, and we ask it to find the property damage, we're asking it to find the property armor, and find the property gun on that serialized object that this is attached to. So then the next chunk is the meat of this particular script. And you can see that it's using onInspector GUI. And of course, it opens up in the other window. When you look at the GUI scripting guide, you're going to see that everything talks about onGUI, not onInspector GUI. onGUI is primarily for what you would be doing inside your game. And what we want to be doing here is using the onInspector GUI, and that's, you can see that's part of the editor namespace. Now, it's worth noting that both onGUI and onInspector GUI can be used in editor scripts. onInspector GUI will be used when making custom editors or custom inspectors. onGUI will be used, however, when making an editor window, a material property drawer, a decorator drawer, or in our case today, property drawers. So we'll notice that when looking at the scripts today, onInspector GUI in our editor scripts and onGUI in our property drawers. Property drawers, how do you say that? We'll also see two different classes being used to draw items in these scripts. GUI layout and editor GUI layout, as opposed to the functions onGUI and onInspector GUI, which relate to the base classes that the scripts we're working on derive from. We're going to be deriving from either editor for our custom inspector, or we'll be deriving from property drawer for our property drawers. And so these classes, GUI layout and the editor GUI layout, they can be mixed within either of these GUI functions, the onGUI or onInspector GUI. The editor GUI layout will contain definitions of items specific to the editor, like property field or indent level. The GUI layout will contain definitions for items that are more generic to a UI, like a button or a tooltip. And one last note, most of the code we will look at today will be using the layout version of the GUI and editor GUI classes. The layout version will do quite a bit of the automatic formatting of the controls. For more detailed control over the items that we're putting in our inspectors or with our properties, the raw GUI and editor GUI classes can be used instead of GUI layout and editor GUI layout. So for more information on all of this, please check out the links to the GUI scripting guide that I put into chat earlier and will be included in the page when it's put on the archive. And check out any additional links included with this session when we put it up on the archives page. So we want onInspector GUI, and we are also going to be making it public, and we have to override it, because we're going to be overriding the onInspector GUI that Unity is going to be using. So we need to do public, and we need to do override, and then void onInspector GUI. And then inside that, we do the meat of the work that we want to do. And what this is doing is really simply, it's updating the serialized object. It's making an int slider for the two objects, and you can look this up in the, as I said, we're not going to go into the exact details, but the editor GUI layout is where we're going to find our sliders. So we're going to make two sliders with it, and then we're also going to make just a normal property field for that gun object. But what we're going to do here that's a little bit kind of cute, as it were, is we're going to create a progress bar that's going to sit underneath the property itself, so that we have a better visual representation of where that value is. I mean, in one sense, it's represented by the slider. To a certain degree, this is just a little bit of sugar to make this particular demo sing a little bit when it comes onto the inspector, so we can see there's clearly a difference. And if we find that, we can see that we're saying if the property damage does not have different values, and that's when you're doing multi-selection editing, that we then take that progress bar, we update it compared to the value that we're setting in the inspector. So if we save that, I don't think we wanted to save that, did we? because let me just undo that because I don't know what we did. Saving was an automatic habit there, and we don't need to. So now I'm going to enable this by putting this back into the editor folder, and then we can look at our demo object. And we can see now that we have a completely different UI here. And as we move the slider, we're getting that updated health bar, an updated armor bar. You can do all sorts of interesting things here. You could try putting them on the same line. You could, you can rearrange these to your heart's desire. And so, as an example, you can see that we've grabbed a class. We are inspecting it. We've made a custom inspector for that in the editor, and then we can now see that in our inspector. The other thing that we would like to look at, I'd like to look at is if we don't want to write a new inspector for every particular instance of a class. An example would be that you have a serialized class. That serialized class appears in multiple different inspectors. When we've written that that custom inspector, we would have to write a new custom inspector for every single script. So if we made another script and it had similar information or shared information, we'd have to write another custom inspector, so it'd have to be one for my player and one for my enemy. And let's say both had int armor and both had int damage and both had game object gun. And if you wanted to separate that off into its own class and then make an instance of the class in the player and in the enemy, you would have to write a custom inspector for each one. And that's a little bit of extra work. So this is where property drawers, and they look like drawers, like you could pull the drawer out and stick some properties in it, but it isn't. It's a property drawer for drawing a property. And this means that you can write, you can have a serialized class, and you can write a custom display or custom way of drawing that particular class, and it will be the same even if it shows up in multiple different scripts. So an example would be if we had, where did I put it? Scale curve. This was the example. So you have a custom serializable class called scaled curve, and it has a float and it has an animation curve. And if you want to put that into a script where you had a scaled curve, two instances of the scaled curve, and we can put this in another script as well if you really wanted to see that. Let me just get this again out of the, get my drawers, moving all my drawers out so we can see that. And if we then take our testing curve script and we put it on our demo script, we can see that we just have our normal turn down arrows that reveal the instance of that particular class that we have. Again, relatively ugly. And what we can do is we can write a drawer for that. We can write this custom property drawer. And again, it's very similar where you have, you need Unity Editor, and you make a custom property drawer of type scaled curve. And then you can, like writing in any script that you want, you can go ahead and talk about, we've got constants here to give us a place to get started from. And then we go ahead and we grab again our serialized property. So when we have our public override on GUI, and then we are getting in a rect, which is a position. We're getting our serialized property, which will come in from on GUI, and then our GUI content, which is in the form of a label. And we're going to take that serialized property and we're going to find the scale and we're going to find the curve on it by taking our property and doing a find property relative. And then we use the name as a string so we can find scale and curve. So this is where we're going to reach out and we're going to grab our properties. And then we create a slider for the scale. And we're going to put this all on one line. One of the things that you should notice here is that we want to change the indent value. If you look at editor GUI indent level, it's how far those objects get indented inside the editor. And one of the things you have to be careful with, because it's running all the time and Unity is keeping track of all these values, when you monkey with something, you basically have to put it back. So when we're drawing our curve, we want to throw this all in the same line and we don't want it indented. So we're going to grab our indent and you're going to set the current indent level to a temporary variable. And then we're going to set our indent level to 0. And then we're going to create a property field and we're going to create that rect out of the property field here. And then when we're done, we're going to set that indent level back to where it started from. So we don't have to care where it was. We're just saying we're going to grab that indent. Then we're going to set it to 0. Then we're going to use it. And then we'll just sort of put it back where it came from. And so if we use this in Unity, our scaled property drawer, let's go. Let me see if I can bring that up. Demo object. So that was what we had. We can go ahead and put that scaled curve drawer back into our editor folder. And when it compiles, bink, we can see that we now have a scale curve here with a slider, and then we have our little curve button that we can bring up, and we can, monkey with our curve as we want to. So it makes it more compact, makes it better looking. And if we then wanted to create a new script, or actually, let's just do this in my player. We can do that with my player. We can make another public scaled curve, my scaled curve. And we can save that. And when we come back and look at demo object, oh, I may have overridden that because I haven't put it in the custom inspector. So that was a little bit me being cheeky. I went off piece there and it didn't work because I am writing this custom inspector. That's actually worth knowing. I'm writing the custom inspector for this from the ground up. I haven't accommodated for this particular new property, so it's being ignored when I'm writing it. As a matter of fact, if I don't have the stuff in my custom inspector for that, my player editor, then it's going to be ignored and won't be displayed. So when you're writing your custom editors, you need to make sure that you take into consideration everything that you want to do, which is one of the advantages of the property drawer. So let me go back and do what I was going to do in the first place, which was create a new C# script and just say another. I have to move that out of script. Well, it'll work here, but we should probably move it out of scripts. Another testing script. And then in our another testing script, we'll have our public my scaled curve again. And then when we come back and look at the demo object, if we grab that on, another testing script, we can see that we've not written a custom inspector for another testing script. We've not written a custom inspector for testing curves. We've just written a property drawer for that particular class. And so if we had other things like another public int, my int, that's just in a public vector3, my v3, we will just get, oops, save that please. We'll get just normal representations of that inside the editor, completely untouched, unchanged. We've only customized that particular class, that scaled curve class. When looking at attributes, property drawer attributes, you can just apply the appropriate attributes to a variable in your script to tell the editor how you want that particular property drawn. And you use property drawers for that as well, because these property drawers are reducing that amount of work that we need to do to customize the way that that script looks in the inspector. When the inspector renders the components for our script, it will check for each property to see if there is a property drawer defined for that type of property, or if the property has an attribute that inherits from a property attribute. And if there is, then the associated property drawer will handle the rendering of that single property. We do need to define an attribute that derives from the property attribute. So let's go ahead and take a look at one of the examples that you can do here. And if we had, this is the regex example. If you want to just simply display, let me just get rid of this for a second, a public string server address, and you want it to be formatted in the proper format, and you want to throw up an error if it goes wrong. And again, you can have other perfectly normal public string, your name, public game object, your tank model, and then you have your server address. How would you do that? And again, you don't need to write a custom inspector for the whole inspector. We don't need to write one for this particular class. We want to write one for this particular property. And the way that you do that is you write an attribute for it. And so we've got a regex attribute, and it derives from property attribute. And this is just holding data. This is just holding the data that we want for what the drawer will later deal with. So what we've done here is we have a pattern, we have a help message, and then we have a constructor. And we set the pattern and the help message in the constructor. And then in our script, which uses it, we then set that attribute, and we can. I don't really want to go into regex right now. This is somewhat described on the blog, and essentially it's going to test to make sure that we have the correct pattern, and if not, it's going to then throw up an error message. So now what we've done is we've defined our property attribute. We've applied it to this particular property, but we also need to draw it. So this is where we have three objects. You can see how this is getting slightly more complicated. We then need to have our regex drawer. And again, since this is trying to make this neat and even, and you will have this script available for you to be able to download and go ahead and dig through, it checks this, looks at and defines a box. It defines the box for the help box. It goes ahead and checks that property. And again, you can see that we are overriding our UI loop. And then if the check is false, then it goes ahead and throws up the help box. And what that looks like when we're done, let me go ahead and drag that out, put that into our editor folder, because again, this is an editor script, so it needs to go into the editor folder. And if we do our regex example and have that sitting on our property drawer, you can see that we just have our name, Erwin Rommel. And we have a tank model we can drag in. And if we make a mistake in our pattern, and the example that was used was we have a letter instead of a proper 0, we can see that it says invalid IP address, and that pops up down below. It's also good to know that there are some property drawer attributes that are actually built into Unity, and range is one of them. So let me go ahead and add the range attribute to an existing script that we already have. I want to show this one off anyway. It's another example of using property drawers. Public int my int. But you can put a range value in front of it. And this is a built-in attribute that is essentially acting as a custom inspector, because I don't have it up. Yeah, so there is a range there. Another example of using property drawers. If we've got in testing, same sort of thing, where we've got a serialized class, including an enum, and notice that these are all public, otherwise you're not going to get access to it. Then you've got an ingredient as the result, and an ingredient, an array, a collection of potion ingredients. And as long as you've got the ingredient drawer in the editor, and you put testing on the game object, you can see that you've got a drop down. It's nicely formatted, so you can say that the recipe is going to be 1 spoonful of sugar, and 2 cups of milk. And if we didn't have this ingredient drawer, disabling it, again, it's going to be the typical pull down that you have when you have a collection of customized classes. And you can see how in this particular case, it works. There's no problem with, sugar 1 spoon, milk 2 cup. But when you customize your inspector, by doing this, and again, you're doing you're doing it for the serialized class, it becomes far easier. And in the end, it's going to make one, hot chocolate. Whatever. You know what I'm saying. And I'm seeing that Number Cruncher has mentioned reflection. There is reflection going on under the hood in a number of these cases, especially with the property drawers and the attribute drawer. So essentially, that's my taster. Nice and quick. And let's go ahead and throw it open to Q&A. I have not been watching or reading any of the chat up to this point. Like I said, a taster in what editor scripting could be, but I'll make sure that the links are included when this gets put up on the archive on more detail on how to do this. Yeah, the property drawer will target a serialized class. So you can use that serialized class multiple times. So if you had an inventory item that could be on a monster, or an inventory item that could be on a player, and remember, this is for the inspector. This isn't for your game. Some people sometimes get a little bit confused because we're talking about UIs and that sort of stuff. These are for custom displays of the way that you see it in the editor. The 3 tiers when you're dealing with customizing the look and feel of your inspector is that you can write a complete custom inspector. You can write a drawer that works per class in the case of our scaled curve, or you can write a drawer that works per property field, and it doesn't have to be a class, it just can be any particular property field. So the question is, excuse me, I'll need to do this property. So property drawers are just a way that things look in the inspector. Yes. Like the progress bar, would that be an example of a property drawer? Well, that depends. In this particular case, it is a custom inspector. The same code in a property drawer could be used on a class or on a single serialized property. With the exception of the stuff that I showed at the beginning, this is all related to what it looks like inside your inspector. This is essentially a very quick overview of what you'd want for making tools that would make things quicker and easier and simpler for you to deal with your components when they're in the editor. So if you want to be able to quickly edit something like the scaled curve, remember let's take that off, take the drawer off, and let it compile. And you see, it's not that bad. It's just a little bit big and cumbersome, and they'll probably be closed down when you see them. A little bit frustrating. Whereas when you have the editor working, then it's just more accessible and it's easier to manipulate. So depending upon how often you're manipulating stuff in the inspector, you might want to create a custom UI that'll make things easier to use. And a lot of people who are releasing material on the asset store want their components to look really, really sharp. And so they'll write a custom inspector for it. And also in medium to large groups where you have a coding team and an art team and a level design team, then the people who are coding these properties might make it easier on the other team members by making those particular components easier to use. Does this also work for scriptable wizards? As far as I'm aware, Gamma 3 Diego, it does. I have not tried it, but I sort of feel like I can't imagine that it shouldn't. In Mariana 97, can I do an inspector for functions and its parameters? It depends upon exactly what you're doing with it, but you can create custom inspectors that have buttons that do things at edit time. You can create and access functions in a script through the inspector as well. And daughter, if I add those graphical representations for values and sliders like you did for armor damage on the gun, and I use hide and inspector, will those public variables show up in the custom editor? The reason for this question is limiting editability of property to people that don't have the custom inspector. For example, change color to red or something can notify me that the dev, he is using something that has really high or low values, and debugging can be done before the game explodes. I don't know. Let's find out. Custom inspector. Well, let's just bring it up this way. My player editor. We're doing serialized properties here. Let's look at the base class first. My player. Now, if we do hide an inspector on the armor, I'm thinking, let's just see what happens. And come back to our demo object. Okay, so it's being overridden, which makes sense by the drawer, because if it's not defined in the drawer, it's going to be ignored. So let's look at the editor. I don't know how this will work on a serialized property. I've not tried it. It seems to be ignored because we may have competing attributes, because things like hide an inspector makes me wonder whether that's also competing with a custom inspector. Goodridge Entertainment, can we download some examples or anything like that? If so, can we please give a link? You're talking about these particular examples. They will be included. I'll include all of these examples on the website with the archive when we're done. DCN Rowley, how did you call the regex attribute using only regex? I believe that the word attribute is actually swallowed. Because if you look at system serializable, I believe that this is system serializable attribute. And so as far as I'm aware, that when you set these up with the word attribute, regex attribute, you then only address it using regex, and attribute, which I probably should have mentioned, is essentially swallowed. It's assumed, so you don't need that part. The pick and play. I need to programmatically in C# make it so the player, upon collision with a deleted link game object, is reset to the nearest checkpoint. Can you help me, please? Unity docs and Unity YouTube tutorials don't help. I've tried everything. The pick and play. You'll need a tag. You'll need some way of identifying the object. And I'm not going to go into all of the detail here because it's a little bit off topic of what we're doing today, but I'll try to help out. You're going to need some reference, a string or a tag. Public string tag to find. Something like that. And then using onTrigger enter. So when and there are ways that you have to make sure this is set up. So if you haven't done Rollerball and you haven't done the Space Shooter tutorials, it's probably worth running those to get an idea of how onTrigger enters work and that sort of thing. onTrigger enter, and so we have a collider, not a color, collider. We'll just call it other, and then if you want to say if the other.tag is the same as tag defined. Worried that that's not completing. Then do something. And then your do something would be, whatever you want to do. I mean, you could write it in that particular space or, somewhere else. However you want it to, the game object or looking to transform equals spawn point. And you could have the transform of the spawn point you wanted to go back to a public transform spawn point. And so, they're very simple script. I mean, you probably want to have it slightly more complicated, but the idea is that you have the string. You could put that string here and ignore the public variable if you wanted to. If you had that spawn point, wherever it needs to go back to, you could do, you're saying the transform position equals that spawn point, spawn point position. You could even simplify it by saying on awake. So you could, when you start the game, you could create you could have a private vector3 called spawn position. And then you could just say that my spawn position is equal to my my spawn point transform, my spawn point dot position. And then you don't have to find it every single time you get reset. Sorry, I missed one. Shock Media. How do I add sound to a UI animated button? I did not find any help on this. I believe it's just when you're doing the click that you'd make a public function. I would assume that when you added your button component, UI button, that you would have a script, and that script would be a button play sound. A public void play sound now. And then you would, do an audio.play. Though what I would also suggest is that you might want to, the shorthand to audio may go away in 5. I believe it's one of the things that the shorthands that are going to be removed. So you'd need to grab your audio component, somehow, either making it a public or private audio component, and then audio source. So you'd need a private audio source. Audio source. And then in I would then say my audio source is the same as get component. And then it would be audio source to play. And assuming that was there, you should be able to let's give ourselves a slot, and then play button sound, play sound now. And you might be able to do something more clever, and then include a parameter and have the slot there as well. But that's generally the trend that I would expect for you to be able to play your sound. And daughter, there is an option to move the center of mass of a rigid body. Can it be easily done in a custom inspector so you can use the transform gizmo or something like that to move it in the scene editor? You probably could. You'd have to fuss around with it, but I mean, the rigid body center of gravity, center of mass, center of gravity, rigid body. And let's switch to scripting. Switch to scripting. Button keeps moving around. Center of mass. You can definitely set it here with a script. And if you can set it here with a script by just saying rigid body center of mass, you should be able to write a custom inspector that shows it. And you should be able to put a gizmo on it so you could see it in the scene view. Considering we're already 20 minutes past closing, not sure I really want to do that tonight, but certainly that's a direction to go for and see if you can get it to work. Cool. Any last absolutely burning questions? And don't forget, you can get a hold of me in the teaching section if you have anything that's a little bit more complicated. Otherwise, I should go ahead and wrap up the session. Cool. Anyway, so I'm gonna go. Thanks for coming. Deeply appreciated. Follow us at Unity 3D. Follow us at The Ant Ranch. That's me. Follow us at Will Goldstone. Follow us at Matt Mirrorfish, which is Matt Shell, who will be back on in a couple of weeks' time. And then follow us at Mike Geig. I hope you had a good time. I did. Anyway, I'll talk to you later, and I'm going to go off mic, and I hope you have a good evening.